Hi everyone, I'm Mackenzie Petrofesso, the Associate Marketing Manager for Soft Tissues. Today I'm here in the core and I'm going to give you a closer look at our DermaTrue process. This is the initial processing step in our ADM pipeline. First, the tech will take the tissue out of its packaging and sterilely place it on the field. Next, you can see the tech using a device called an amalvatome to remove the top adipose layer. An amalvatome is a device that's designed strictly for tissue banks due to its rotary blade. This device is very sharp, therefore the tech must be very careful using sweeping motions to not cut the dermal layer. Typically, the tissue that we get in full thickness recoveries comes from the back, the stomach, the thighs, and the knees. After the top layer of the adipose has been removed using the amalvatome, the tech will then go in and begin to clean up the edges. She's also evaluating the skin to ensure that it meets all ADM spec requirements, including no hair, stretch marks, scarring, or tattoos. After the tech removes any imperfections in the tissue that don't meet the spec, she will then continue the process of removing the adipose layer. The amalvatome only removes the top layer of the fat. The tech must use a gouge to remove any adipose that remains within the deep dermal pores. This gouge is very sharp and can easily score and compromise the tissue. Therefore, the tech must be very careful and gentle while gouging the dermal side of the tissue. The final step in the initial process is to get the dimensions of every piece of tissue. Here you can see the tech running the tissue through the thickness gauge. Next, she will get its weights in grams. And last, she will get the total area of every piece. This donor in specific was 3,900 square centimeters, with the thinnest portion being 0.8 millimeters and the thickest portion being 3.3 millimeters. The tech will place the tissue in a K-pack where it will be frozen down until it's planned for its next step. The next step in the ADM process is to initiate the delamination of the epidermal layer of the skin. Prior to this, the tissue is removed from the freezers and fully thawed. The tissue is gently rinsed and placed into jars full of solution. The jars are thoroughly mixed and incubated in shakers for up to 60 hours before the decell process begins. After the incubation time is completed, the tissue is removed from the shaker and the decellularization process will begin. First, the tissue is rinsed and placed dermal side down. Next, the tech will gently run a gouge over the top of the epidermal layer of the tissue to delaminate the skin, leaving only the dermal matrix. Here you can see the tech running the gouge over the epidermal side of the tissue one final time to ensure the tissue has been fully delaminated. Next, the tech will run the gouge on the dermal side of the tissue to get out any excess adipose that may still remain within the pores. Finally, the tech will do a 5-point thickness verification to ensure the tissue is not over 3.3 millimeters thick. After every piece of tissue's thickness has been verified, the tissue is rinsed in the sink and placed in new, sterile jars. The tissue is fully submerged in solution, and the jars are placed in plastic bags to keep them sterile while they incubate in the shakers. After every incubation period, the solution is dumped out, and the tissue is removed and rinsed in the sink. Here you can see how much the texture and color of the tissue has changed between the rinses. The tissue will be placed back into the jars, and the tech will manually agitate the tissue in order to ensure that all the previous solution has been rinsed out. After the tissue has been fully rinsed, the new solution is poured into the jars, and the tissue is placed back on the shaker. This process is repeated multiple times and can take up to 7 hours for one tech to fully decellularize the tissue. After all of the rinses have been completed and the tissue is fully decellularized, you can see the flexible nature of the skin as well as its pristine white color. The tech will then verify the thickness to ensure that it has not swollen over 3.3 millimeters throughout the process. The tissue's total area is also recorded. The tissue is then packaged and placed back in the freezers. This was an overview of what our manual decellularization process looks like. Now let's take a look at our automated process. Here is our new cell washer. This is a machine that automates the 7-hour decellularization process and eliminates the need for a tech to manually process the tissue. This will also give us the ability to decellularize tissue up to 4 millimeters thick. The final step in the ADM production process is to split, cut, and package the tissue. These 3 steps happen all in one session. First, the techs will put together the S3 machine. Each part and every tool is autoclaved and individually wrapped after each session in order to ensure the sterility of the tissue. The process of assembling this machine takes 2 techs. One tech who is sterile to put together the machine, and another tech who is non-sterile to unwrap each piece of equipment to the tech. This on average takes around 30 minutes to assemble. The S3 has increased the quality of our product by ensuring thickness uniformity throughout the entire graft, which is something that is very crucial for all of our ADM applications. Here you can see the tech assembling the last piece of the equipment. As soon as this is completed, they will take the tissue out of the fridge and begin to process it. After the tissue is placed on the field, the tech will take the initial thickness in order to decide what product they will produce based off the demand. The tissue is then rinsed and placed on a carrier that it will run through the S3 machine on. The tech ensures that the tissue is very flat, and then they will set the machine based off the thickness and the product that they want to produce. The tissue is then loaded onto the S3 machine, and the tech will begin splitting the tissue. As the tissue runs through the machine, the tech will gently guide it through. After the tissue is split, the tech will then check the thickness again to ensure that it was split to the exacting specifications. Here you can see the tech using a stamp to score the tissue where she will cut on the indentations. The other tech looks over every graft to ensure that it meets all of the quality specifications. Instead of the techs having to cut the grafts by hand, this is one of our 2 new die-cut presses. These presses have the ability to cut and mesh our Alloman products to exacting specs with clean cut lines. Once the tissue has been cut and it's ready to be packaged, The tech will perform a 5-point thickness verification on each graph in order to ensure the thickness uniformity. The tech will then place the graph on sterile backing and into its final K-pack and chevron. Once the graphs are fully packaged, they will be sent out for E-beam terminal irradiation. After irradiation, the graphs are placed into aluminium boxes and ready to be sent out.